Hey there, Math Explorers. Welcome back. Today, we're entering the world of sets, a simple but powerful idea in math. By the end of this lesson, you'll be able to identify sets, subsets, and elements and write them correctly using set notation. Now, let's jump in. Now let's have some key terms and definitions. First is the set. Set is a collection of distinct objects. For example, think of your school bag. Inside it, you might have a notebook, a pencil, calculator, and a ruler. This group of items is an example of a set. Another example, your classmates in a classroom form a set. Now each student is part of the group, but no one is listed twice. And we write a set using open and close braces. Another term is the element, in which an element is an item inside a set. So basically, each of these examples, so the notebook, pencil, calculator, and ruler, each one of them is called an element. Now, based here, as you can see that pencil is an element of a school bag based on a given. So we write it like this. Pencil. And then let's call our school bag, let's label this as set A. Okay, for now. Okay, so pencil is an element of set A, which is a school bag. So the symbol for having an item as an element of a set is like this. Okay, it looks like a letter E, a capital E, but like that. Okay, so pencil is an element of set A, which is the school bag. And again, this symbol here, the symbol means is an element of, and I hope that's clear. Oh, let me write it down. So again, this means as an element of. Next, our key term here is a subset. Now, imagine if you have two sets. Set B is a subset of set A if all elements of B are also in A. Now, the symbol for this one would look like this. It looks like a flat C with an underline. Now, let's go over with the two sets. Set A, we have here a set of sneakers, boots, and sandals. For B, set of sandals, sneakers, and boots. As you can see here, despite the order, in A, we have sneakers, boots, sandals. In B, sandals, sneakers, boots. Despite the order, all elements from B are also present in A, which means B is a subset of A, given that A is our original set. So that means a subset can be equal to the original set. Now, before I tell you something regarding about the greater than, less than, and equal, let's have another example in which it's not equal to the original set. Let's have set C. In set C, we have I just have one sneakers, perhaps. As you can see here, in set C, we only have one element, which is the sneakers. Is sneakers part of set A in general? Obviously, yes. Which means that set C is also a subset of set A. Now, as you can see here in the symbol, it looks like a C, a flat C with an underline. But at the same time, if you were to compare it with greater than, less than, equal, it looks like a less than and an equal sign at the same time. So the symbol of subset could also be pertained to the relationship of less than or equal to. Because just like here in this example, B is actually equal to A, given the elements given. Well, on here on the other side with C as a subset of A, the number of elements is less than compared to the original, which is 3. Here it's just 1. So that means as long as it is equal, or even if it's less than the original, as long as that you can see that each element is present to in comparison to the original, then that is automatically a subset. Now let's have our next term, which is the proper subset. This is when all elements are inside the big set or the original set, but the two sets are not equal. So the symbol for this would just look like a flat C, or if you are to compare it again, this would be less than. So if you are going to base it here on top of the examples, so if you have set A and B, obviously this is just a subset because this is equal to each other. However, if you are going to take account of A and C, because again we have this C is a subset of A because C only has one item, which is less than the original number of our main set, which is set A. So based on that, again, it should be in proper subset. It should only have this symbol. Which would signify less than. So obviously, based on our previous example for the sets, C is not just a subset, but also a proper subset of A. Another thing, if we are to compare, let's have set A, B, C. 1, 2, 3. 3, 1, 2. And C, we only have 1 and 3. Based on this, assuming that our set A here is the original set, we could say that B is a subset of A since B has all the elements of A at the same time, despite the order. Here, this is subset. Whereas for C, it has two type of sets. C could be a subset of A, because again, remember that this one here, this one is less than, obviously. So C is a subset of A, and at the same time, C is a proper subset of A. Subset and proper subset. Just a quick thing, always remember that a proper subset will always be smaller compared to the original set. Remember this. Think of this as less than. So we could say C is less than A. That's it. Next term, we have the universal set, which contains everything being discussed. Now, let's have three sets here. Set A having the elements 1, 2, 3. For B, we have 3, 4. C, we have 1, 5. Which means that the universal set, which we have this, U. So this is equal to all of the elements given. So we have there from 1, 2, 3, 4, and 5. So basically, all of these sets and elements came from the universal set. We now have the empty set or null set, which means a set with no elements. So there are two ways on how to have the symbols, write the symbols for this. You either choose this one, like a 0 with a slash, or a symbol for set. But as you can see here, you can't see any element inside. So yeah, and that's it. For example, we have set A, in which the element or elements being described here are natural numbers less than 0. And we know for a fact that natural numbers start with 0. That means there is no natural number that is less than 0, which means set A is an empty set. Okay, you just choose this symbol or this, your choice. Let's have set B pertaining to empty set. Set of days in a week with a day in a week with 30 hours. Obviously, there is no day in a week with 30 hours because the maximum number of hours in a day is just 24. So that means set B is also an empty set or a null set. And that's it for this type of term. Now, let's dig to the concept of empty set as a subset. Now let's have a question. Is the empty set a subset of any set? The answer is yes and always. But how? Why is an empty set a subset of every set? Now let's go back to the idea of a subset. A subset means all elements of A must be in B. Now think. The empty set has no elements, obviously. Since there is nothing to check, nothing breaks the rule. So that means the condition is always true. Next term, we have the roster or listing method. We list all the elements inside the braces. Now, situation, set A is the set of the first 4 counting numbers. So we know that the first counting numbers start with 1, so we get to have 1, 2, 3, and 4. So we write it this way. A is equal to 1, 2, 3, 4. Now we read this as set A is the set containing 1, 2, 3, and 4. Again, listing method or roster, you just list all elements. Another thing, if the situation is set B is the set of months in a year. So just write all the months inside, or just write a list all the months inside the braces. So from January, February, March, April, May, June, July, August, September, October, November, and December. And as you can see, even from earlier, you don't need to have the word And if you have it inside, the braces, so you just need to list all the elements and you just need commas to do their work. Yeah, and that's it. Next to listing method is we have the set ability notation, which describes a set using a rule. Now, we have here an example of a set ability notation. So we read this as A is the set of all x such that, okay, so this is read as such that, and then you go over to the rest, such that x is less than 5. Next, for set B, we read this as B is the set of all x such that x is a color of the rainbow. So you know the color of the rainbows, right? The rainbow, right? The Roy G. Biv. Now here, as you can observe, is a color, or you could just focus on color. If you write this, if you write a ruling based on a set ability notation, it needs to be in a singular form, not plural, because we are talking about an element. So obviously element is just singular, so you base it on that and not plural. So if we are to add another example here, so let's gonna talk about months again. So C is the set of all x such that x is a month. Okay, still singular, of a year. And that's it for set ability notation. And just a recap of the previous symbols. So we have here for the first one. So this one is an symbol for element. So we read this as an element of. Second, we have a slash here. So obviously it signifies not. So this is not, it is read as is not an element of. Third, we have here the subset. So it's a subset of. Fourth one, we have the proper subset. So it's a proper subset of. If we are to add another based on earlier discussion, so we have this, or okay, so set, a certain set is an empty set. Okay. This time, let's try to identify elements. Now, our set A here contains apple, banana, and cherry. So, based on this, is banana an element? So yes, obviously it is an element. So we write this. Banana is an element of A. For mango, it is not there. So obviously mango is not an element of A. Wait. Okay. Last one we have for cherry. Obviously cherry is there, so cherry is an element of A. Another example we could take, let's have set B. So we have 2, 4, 6. So it's just easy. So we have here 2, 3, 4, 7, 6. So we have A, B, B, B. So is 4 an element of B? Obviously 4 is here, so 4 is an element of B. And unfortunately, 7 is not an element of B, so we write this symbol. And last one, is 6 there? Yes, so 6 is an element of B. Let's have listing or roster method activity here. So write each set using the roster method. Let's assume 1, 2, 3 as set A, B, and C. So for A, so we get to have here the vowels inside the word cat. So it's only A, so we just write it like this. For the second one, the first 3 natural numbers. Again, this is natural numbers. So natural numbers start with 0. So B is equal do this 0, 1, and 2. And for set C, primary colors used in painting, so you get to have red, blue, and yellow. Now let's have a set builder notation practice, starting with a set A containing 2, 4, 6, 8. So we could write this in set builder notation. A is a set of all x such that x is an even number. Less than 10. Or you could write it this way. X such that x is even and x is less than 10. So this one here is shorter, so either of the two, both are correct. Second one, we have here B contains all numbers greater than 5. So it could be, it's not just limited to 6, 7, and all those numbers going up. It could also be 5.0001 and all those decimal points or decimal numbers. So if you write this, we have B is a set of all x such that x is greater than 5. Or to write this as short as you want, so this will be x such that x is greater than 5. Now let's have subsets practice. For number 1, let B contains pencil, pen, eraser, and let set A contain pen, eraser. Now here are the questions. Is A a subset of B? The answer is yes, because obviously pen and eraser are both in set B as well. We have here pen and eraser. Okay, that's it. However, is B a subset of A? Although pen and eraser are in both sets, we cannot see pencil being an element of A. So that means B is not a subset of A. So it's just limited to everything you see from both sets, whether it's equal or less than, but it should not have a different element from both. Now let's have a real-life example or explanation as to how the empty set as a subset. Now imagine a lunchbox. Your lunchbox contains a sandwich and juice. If you were to empty it, your empty lunchbox contains nothing. Since it does not contain anything wrong, it automatically fits inside any lunchbox set. Now let's have our second example here. Now let C contain apple, banana, and mango, and set D contain apple and grapes. Question: is set D a subset of C? Well, the answer is no. Since grapes is not found in any of the elements from set C. So that's it. Again, go back to the idea of subset. Here, grapes violate the elements of C. So for D to be a subset of C, grapes needs to be an element of C, or grapes should not be an element of D. It could just have apple for D to be a subset of C. This time, let's have proper subsets practice. Now, first example, let B contain shirt, pants, and shoes, and set A contain shirt and shoes. Question, is A a proper subset of B? But first, let's look at the examples here. I mean the elements. We have shirt and shirt. Present. Shoes and shoes. It's also present. So this would give us the idea that A is a subset and at the same time a proper subset of B. Now, let's focus on proper subset. Remember this, that this symbol would also signify less than. So if as we write this, A is less than B, because obviously there are 3 elements here and there are 2, and these two elements are present in the 3 elements or in the set of B, which means A is a proper subset of B since all are inside of B and A is smaller. Last example, let C contain red, blue, and green, and set D contain green, red, and blue. Question, is D a proper subset of C? Again, we need to be reminded that this symbol here signifies less than. So base here we get to have green, green, red, red, blue, and blue. Since both sets are equal to one another despite the arrangement of the colors or elements, this one here is a subset and not a proper subset. Okay, so since they are equal, proper subsets must be smaller. Great work today! Today you learned how to identify sets, name elements, recognize subsets and proper subsets, and write sets using listing and set builder notation. Practice more and you'll master sets in no time. See you next lesson.